The other method of calculating bounce light or indirect illumination in 3ds Max with mental ray is called global illumination. It's very useful for scenes that have a wide variety of lighting conditions and contrasty scenes. However, there are very complex adjustments that need to be made in order to get an acceptable render quality. Lots of give and take and lots of test renders. This can tend to be a trial and error process, especially for someone who's new to the global illumination rendering tools. To give us a simple overview of what global illumination is actually doing inside of mental ray, we need to understand a little bit about the technical part of how light works. Now, we don't want to get overly technical, so this will be a simplified overview of what happens. Light works in two ways. It can function as a wave, or it can function as a particle. The particles of light are called photons. These are emitted from a light source out into the environment. Each photon contains a certain amount of energy associated with it, as well as a color value. So if we have a bright, pure white 100-watt light, the photon coming from that will be a pure white and will have an energy value of 100 watts. When that photon hits a surface, it loses some of its energy, and when it bounces, it picks up some of the color from that surface, then transfers it to the next surface that it hits. It also loses energy at the same time. And this happens until the amount of energy in the photon has been reduced to zero. The way mental ray uses photons is very similar. It shoots photons out from each light source in your scene and calculates the amount of energy that each photon has, as well as the original color. It then follows each photon and figures out what geometry that photon hits. It looks at the material that's assigned to the geometry and calculates what color the photon should be and how much energy it will use when it hits that surface, and transfers that energy to the coloring at the point where the photon hit the surface. The photon then bounces onto the next surface, and the process repeats until the photon has lost all its energy. The end result is what is called a photon map, which is basically a three-dimensional picture of where the photons in the scene have struck a surface and then left their energy impression. This map is then used to render the final image.